When people first hear AI agent, they often imagine one big answer. In production, that is not what I trust. A useful agent is a system that keeps moving toward a goal in checked steps, and that loop is what makes it more than a chatbot. The loop is simple to name but important to understand. The agent starts with a goal, reasons about the next move, takes an action, observes what came back, verifies whether that result helped, and then either continues or stops. Think about a failed deployment at 2 a.m. A real incident agent cannot solve that with one speech. It may need to read deployment status, inspect logs, compare rollback results, and decide whether escalation is required. That is looped work. In this video, I will define the AI agent loop clearly, show the core flow, walk a practical example, and explain the production guardrails that keep the loop useful instead of dangerous. Start with the definition. An AI agent loop is a controlled, repeating cycle of work where an agent receives a goal, gathers context, takes action, observes the result, verifies progress, and continues until the task is completed, blocked, escalated, or stopped by a rule. Here is the basic mental model I want you to remember. Goal, then reason, then act, then observe, then verify, then continue or stop. If you can see those stages, you can understand almost any serious agent design. You can also picture it as a system flow. A user goal enters the agent. The agent reasons about the next step. It uses a tool, code path, or approved action. It receives an observation, verifies what that means, and then stops or repeats. By the end, you should be able to separate a real agent loop from a marketing demo. If there is no clear goal, no observation, no verification, or no stop condition, it is not a production quality loop. A chatbot turn and an agent loop are not the same thing. A chatbot mostly answers the current message. An agent loop keeps state around a goal and may work through several steps before it returns a useful final result. The goal matters because it anchors the whole cycle. Without a clear goal, the agent does not know what success looks like. It may keep wandering, call unnecessary tools, or stop too early with something that only sounds plausible. Reasoning in the loop does not mean magic. It means the agent compares the goal with the latest evidence and chooses the next bounded action. In good systems, that action comes from an approved toolset, not from unrestricted improvisation. Verification is what makes the loop controlled instead of repetitive. The agent should ask, did this result actually reduce the problem? That is different from asking whether the tool merely returned some data. Step 1 is goal. This is the job to be done, written clearly enough that the agent can measure progress. Good goals are specific, scoped, and tied to an expected outcome, not vague instructions like handle everything for me. Step 2 is reason. The agent looks at the goal, the available tools, and the latest context, then chooses the next move. In production, this should be cheap and disciplined. Reasoning is there to guide action, not to generate endless internal debate. Step 3 is act. The agent uses a tool, runs code through a safe wrapper, queries a system, or writes a controlled update. This is the point where the loop touches the real world, so permissions, schemas, and timeouts matter. Steps 4, 5, and 6 complete the cycle. The agent observes the result, verifies whether it helped, and then either continues or stops. That continue or stop decision is the control hinge of the whole loop. Let us use one practical example. A user asks an agent, check why the deployment failed, confirm whether rollback worked, and escalate if customer traffic is still broken. That is a clear goal with a built-in stop condition and a possible escalation path. The first good move is not to open a ticket. It is to reason about the safest next step and start read-only. The agent checks deployment status and recent alerts first, because observation should come before side effects whenever possible. After the first action, the agent observes structured results. Maybe deployment status says failed, rollback says partial, and error rate is still high. Now the loop has better context, so the next step can be log inspection or service comparison instead of guessing. Then comes verification. If the evidence shows customer traffic recovered, the agent can stop with a summary. If traffic is still broken, it can escalate through an approved workflow, such as opening an incident or paging on call. The loop keeps going only when the goal still is not met. The first failure mode is a fuzzy goal. If the agent is told to fix the problem without scope, it may chase symptoms, mix unrelated systems, or spend tokens and time without closing the real issue. Bad goals create noisy loops. The second failure mode is skipping verification. Some teams mistake any returned payload for progress, but a log dump, API response, or search result is not success by itself. The loop needs a real check against the original objective. The third failure mode is unsafe action power. If the agent can run raw shell commands, raw SQL, or open-ended cloud admin actions, the loop becomes an unreviewed automation path. That is how mistakes turn into outages or data exposure. The fourth failure mode is missing stop rules. Without budgets, retry limits, escalation thresholds, or human approval gates, loops can run too long, spend too much, or keep repeating the same low-value action. A better loop starts with bounded tools. Each action should have a clear name, strict inputs, expected outputs, permission rules, and owner. That makes reasoning safer because the agent chooses from governed capabilities instead of inventing raw operations. Strong loops also keep useful state. They remember the goal, the steps already taken, the latest evidence, and the remaining budget. That checkpointed state stops duplicate work and makes handoff or retry much easier. Next, add explicit control rules. Use verification criteria, retry caps, max step counts, timeout budgets, and approval gates for right actions. The agent should know when to continue, when to ask a human, and when to stop. Finally, make the loop auditable, log the goal, tool calls, results, verification outcomes, and stop reason. If a team cannot explain why the agent acted, they cannot truly trust or improve the system. So what is an AI agent loop? It is not magic and it is not one giant answer. It is a controlled cycle where the agent moves toward a goal through repeated reasoning, action, observation, and verification. Keep the core shape in mind. Goal, reason, act, observe, verify, continue, or stop. That simple frame is powerful because it helps you inspect safety, quality, and usefulness at every step. My practical rule is this: never reward motion alone. Verify that each step reduced the problem before you allow the next one. That one habit will improve both safety and result quality. If you want more practical engineering breakdowns on AI agents, cloud systems, Terraform, and production delivery, subscribe to Trustscrin Cloud and AI Engineering. We are building more lessons around how these systems work in the real world.